Hello everyone. Yesterday in the part 3, 3a and 3b, I uploaded two videos on the graphs of this linear, quadratic and cubic polynomials. Okay, after finishing that two, in the part 3 itself I will send one more video, that is 3c, that is in the page number 57. We have tried this. Look at here. We have tried this. Okay, try this. I'll look at here. What is the question he gave here? Find the zeros of the cubic polynomials. We have to find out the zeros of the cubic polynomials. Here he gave three questions to us, that is these three are cubic polynomials. Look at here, the first question which has the highest power 3, that is monomial, but it is a cubic polynomial. It is binomial. Why? Because it has two terms, but the highest power here it is x square minus x cube, and the highest power of this variable x is 3, hence it is a cubic polynomial. Here in the third question also, you just look after the x is a variable, but here the power is 1, here the power is 2, here the power is 3. The highest power of this cubic polynomial is 3. Hence it is a cubic polynomial, without drawing the graph of the following. No need of drawing this graph for this cubic polynomials, but we have to find out the zeros of the cubic polynomial. Okay, first of all, in page number 57, try this. Okay, the first question, that is minus x cube. We have to take this polynomial as given that the polynomial p of x is equal to minus x cube. Minus x cube. The zero of the polynomial. The zero of the polynomial. That implies minus x cube is equal to 0. That implies you just separate this 3x. Okay, 3x to the power of 3 means we have to multiply this x terms into 3, right? Minus x into cube is only for x, okay, not for the minus. Minus x we separated, and x into x, that is equal to 0. How many terms we have here? How many x variables here? 3, right? You just equate this all with 0. With 0. Then it becomes x is equal to minus x is equal to 0. X is equal to 0. X is equal to 0. Okay. Minus x means we can write this minus x if you just multiplied with the minus for both of this 0 and x, it becomes minus of minus plus, then minus 0 means that there is no negative for the there is no positive and a negative for the 0, hence it becomes x is equal to 0. How many zeros we got here? 3 zeros. So these 3 are the zeros of the given polynomial. It is a solution. Okay, these are the zeros of the given polynomial. The second sum, that is x square minus x cube. Okay, the second sum is x square minus x cube. Given that the cubic polynomial is p of x is equal to x square minus x cube. The zero of the given polynomial. The zero of the polynomial. Okay, that implies x square minus x cube is equal to 0. That implies we just take the common term of these two terms. X square is the common term, is it? X square is the common term. When you take this x square from this term, you have only 1. Okay, that minus x is there here. That is equal to 0. We just separate these two terms, that is x into x of 1 minus x is equal to 0. We just equate these terms with 0. Here we have 3 terms, that is we are separating and equating with the 0. X is equal to 0, first one, and x is equal to 0, that is second one. The third one, 1 minus x is equal to 0. You just take this x into other side. So then you will get x is equal to 1. So x is equal to 0, 0, 1 are the zeros of the given polynomial. Here 0, 0 and 1 are the zeros of the given polynomial. Okay, what is the third one here? X cube. Here the third one is x cube minus 5x square plus 6x. Okay, so given that the cubic polynomial is p of x is equal to x cube minus 5x square plus 6x. Okay, the zero of the polynomial is equal to x cube minus 5x square plus 6x. The zero of the polynomials means you have to equate this polynomial is equal to 0. Okay, you just take the common term of these terms, x is the common term in all the terms. So the remaining what remaining here remained here, that is x square minus 5x plus 6 is equal to 0. Okay, we just equate this one with 0 for both of these terms, that is equal to x is equal to 0. I just leave this one. So what is the second one? X square minus 5x plus 6 is equal to 0. We have to factorize this one. So how we are factorizing these terms? Like this, right? So the first term and the last term, and you just make the polynomial in the order. Okay, order wise. First the variable which has a square, then x term, then constant term. Just like that you have to make the equation in a order. Okay, the first term what it was? X square into 6x square. So then what are the two terms? We have to take that sum must be equal to 5. Okay, 3 2s 6. X square also I want here, so x into x. 3 2s 6, x into x square. But minus 5 we have here, right? So I want to take two negatives, that is minus 3x minus 2x. These two are negative terms, but we have to add. Then you will get minus 3x minus 2x, then it will get minus 5x. Is it? 3 plus 2, 5. 3x plus 2x. 3x plus 2x is equal to 5x. The negative term has to be remained here. Okay, the first term has to write like this and the last term as usual. In the first two terms, what is the common term here? X. So 1x is taken into as common. So x minus 3. In these two terms, minus 2 is the common term. X minus 3. Why it is minus 3? Minus of minus plus it becomes, and 2 3 6. Okay, that is equal to 0. In these two terms, what is the common element? That is x minus 3 is the common. So x minus 3. After taking this common element from this term, what is remained here? X. Here minus 2. That is equal to 0. We just equate these two with the 0. Then x minus 3 is equal to 0. X minus 2 is equal to 0. X is equal to, it becomes 3. X is equal to 2. Like this. Okay. So here how many zeros you will get? You got here 3. What are the zeros? The zeros of the given polynomial are 0, 3, 2. Okay, 0, 3, 2. These are the zeros of the given polynomial. Hence here we finished this. Try this, right? Then after you just look after here. Okay, example 1. So in the example, page number 58, example 1. Is it? The first graph, look at here, just like this you just write in your notes. Okay, it is x-axis, it is y-axis. How the graph it looks? Like this. Okay, like this. How the graph it looks? Like this. What he was asking from the question, look at the graphs in the figure given below. Look at the graphs in the figure. Okay, each is the graph of y is equal to p of x. When p of x is a polynomial, in each of the graphs find the number of zeros. We have to find the number of zeros for the graphs. The first graph here, look at here, I drawn here in the notes. How many times this curve which touches x-axis? Only once, right? On x-axis we have to look after, no need to find this y-axis. Okay, p of x it was. So how many times it touches the x-axis? Only once. How many zeros you will have? Only one. Why? Because from the graph there is only 1 zero of the polynomial p of x. Polynomial p of x. You just underline this 1. 1 0. Okay, 1 0. So the second graph here. The second graph it looks like this. Right? So the U shape downwards like this, right? The U shape downwards, x, y. How many times this U shape we touches the x-axis? Here 2 times. So from the graph there are 2 zeros of the polynomial p of x. So you just underline this 2. Just like that. Third one, the same as usual, you have to write in your notes. Okay, how many times this graph which touches? 1, 2, 3. 3 times. There are 3 zeros for this polynomial. Here, how many times this linear equation? Here it is a linear equation, right? This linear equation, how many times it touches the x-axis? Only once. There is only 1 zero. Here, it is a quadratic equation. Why? Because it is in U shape, right? Quadratic equation, how many times it touches the x-axis? Only once. When I said no yesterday. So, in case 1, when U shape it touches 2 times, it gives 2 values for the x. When it touches only once, it gives 2 values but equal values. X will get 2 values but the values are same. The values are equal. The values are same. Okay, then it is a quadratic equation, but the x value it gives 2 values but the values are equal. Just like that. How many zeros we have? Only once. Only once it touches the x-axis. So this curve, how many times it touches the x-axis? 1, 2, 3, 4. 4 times it touches the x-axis. There are 4 zeros for the given polynomial. Just like that. Just like this, you have to write the answers for this example 1. Okay. Then in page number 59 we have example 2. Okay. Page 59. Example 2. So here, what is the question? Find the number of zeros of the given polynomials. Find the number of zeros of the given polynomials and also find their values. We have to find their values. Okay, number of zeros we have to solve it. We have to tell the number of zeros as well as the values also we have to find out. Okay, what is the first question he was given here? Given that the p of x is equal to 2x plus 1. The 0 of the polynomial we have to find out, right? The 0 of the polynomial. That implies 2x plus 1, that is equal to 0. That is equal to 2x is equal to plus 1 when it moves into other side of this equation, equating, then it becomes minus 1. That is equal to x is equal to minus 1 by 2. How many zeros you got here? Only 1, right? Why? Because it is a linear polynomial. For the linear polynomial, how many values you will get for the x? Only 1, right? So the 0 of the polynomial is minus 1 by 2. That's it. Okay. Second one. So q of y is equal to y square minus 1. Y square minus 1. Given that q of x is equal to y square minus 1. The 0 of the polynomial. That implies y square minus 1 is equal to 0. That implies y square is equal to 1. That implies y is equal to square root of 1. That implies y is equal to, when the square roots, it gives the exact values, that is positive, and your negative values it will gives. Okay, hence it is not equal to only 1. It is equal to plus or minus 1. Hence you will get y values as plus 1, comma y is equal to minus 1. So here two values you will get from the root, two values, that is positive value as well as the negative value. Okay, just remind it. The zeros of the polynomial is plus 1, comma minus 1. These two are the zeros of the given polynomial. Okay. And the third one, already I said to you, that is r of z is equal to z cube, right? So given that r of z is equal to z cube, the 0 of the polynomials, that implies z cube is equal to 0. How many times we have to write here? 3 times. Then z into z into z, that is equal to 0, right? So we have 3 z's here, right? 3 z's, he has to equate this with 0. Okay, then you will get z is equal to 0, z is equal to 0, z is equal to 0. How many zeros you will get? 3. The zeros of the given polynomial. Zeros of the polynomial are 0, 0, 0. Okay, these are the 3 zeros of the given polynomial. These 3 are equal, no? Hence we can call it as the 0 of the polynomial is 0. Okay, why? Because these 3 are equal. Okay, hence we finished this example 2. We entered into the exam, that is exercise 3.2. As usual, already I said to you, this example 1, just like example 1, you have to write this first Roman. Okay, look after here. What is the question he gave here? The graph of y is equal to p of x are given in the given figure below. For some polynomials p of x, in each case find the number of zeros of the p of x. You have to write just like this. Okay, is this straight line which touches the x-axis? No, there is no zeros for the given polynomial. There is no zeros for the given polynomial. What is the solution? From the above graph, the line which does not touches x-axis at any point, hence there is no zeros for the given polynomial p of x. In the second, how many times it touches the curve? Only once, right? So it touches only once. The curve which touches the graph touches the x-axis at only once. Hence there is only 1 0. Here in the third question, how many times this curve which touches the x-axis? 3 times. 1, 2, 3, right? 3 times. So here you have tried from the graph the curve which touches the x-axis for 3 times. Hence there are 3 zeros for the given point. Just like that you have to write right here. Look at here. You can calculate this last one. 1, 2, 3. Only 3 times it touches. Okay, 3 times. There are only 3 zeros for the given polynomial. Okay. The second question. So exercise 3.2. Second Roman. Find the zeros of the given polynomial. Find the zeros of the given polynomial. So first sum, given that the polynomial p of x is equal to 3x. Given that the polynomial p of x is equal to 3x. The zero of the polynomial 3 of x is equal to 0. That implies x is equal to 0 by 3. That implies x is equal to 0. Okay, if 0 is there in the numerator, the number which becomes 0. Hence 0 is the 0 of the given polynomial. Okay, the second sum, that is given that the polynomial p of x is equal to x square plus 5x plus 6. So the zero of the polynomial that implies x square plus 5x plus 6 is equal to 0. We have to find out the zeros of the by using of this factorization, that is like this. So 6 into x square, 6x square, 3 2's 6, x into x square plus 5x we have. So we just keep 2 plus in front of these two numbers. So x square, the first number as usual you have to write, the last number also as usual you have to write like this. So from these first two terms, what is the common element? That is x. What is remained here? X plus 3. What is the common in between these two? 2. Okay, x plus 3. 3 to 6, no? Just like that I have to take this 2 as a common. Okay, in these 2, x plus 3 is the common. What is remained here? X plus here 2. That is equal to 0. You just equate these 2 with 0. Then it becomes x plus 3 is equal to 0. X plus 2 is equal to 0. X is equal to minus 3. X is equal to minus 2. How many zeros you will get here? 2 zeros. There are 2 zeros. Only we have to find out the zeros of the given polynomial. The zeros of the polynomial is equal to minus 3 comma minus 2. These two are zeros of the given polynomial. The third question, what you have here, given that the polynomial p of x is equal to x plus 2, directly he gave like this. So the zero of the given polynomial, that implies x plus 2 of x plus 3 is equal to 0. That implies x plus 2, you just equate directly, he gave like this. Okay, x plus 2 is equal to 0, x plus 3 is equal to 0. It is very easy, no? So minus 2, x is equal to minus 3. Just like the above sum, you got minus 3 and minus 2. Okay, so the zeros are minus 2 and minus 3. Okay, fourth sum. So here given that the polynomial p of x is equal to x to the power of 4 minus 16. Just like this. Okay, this fourth root polynomial. If the highest degree is 2, you will call it as a quadratic polynomial. If the highest degree is 3, you will call it as a cubic polynomial. If the highest, what is the highest degree of this equation? 4. The power is 4. The highest degree is 4. Then we call it as a fourth degree polynomial. Nth degree polynomial we saw at the introduction part, no? Nth degree polynomial, the highest power, if the highest power is x to the power of n, if the highest power is n, that we call it as a nth degree polynomial. Just like that, here the highest power is 4, then we call it as a 4th degree polynomial. How can we solve this equation? Okay, in the simple technique, by using of this, the 0 of the polynomial, that implies x to the power of 4 minus 16 is equal to 0. That implies you just change this x to the power of 4 into x square whole to the power of square. Is it right? Is it right? Yes, x square whole square means just like this, a to the power of m into whole to the power of n. That is equal to, what is the formula? A to the power of m into n. Just like I converted this as x to the power of 4 means x square whole square means 2 2's 4 as usual. We just convert the 16 into 4 square. Is it okay for you? 4 square, that is equal to 0. How it looks like? A square minus b square. What is the formula for this a square minus b square? That is equal to a plus b into a minus b. Okay, a plus b into a minus b. We just change this as like this. That is equal to, a means x square plus 4. Again, a minus b means x square minus 4. That is equal to 0. That is equal to 0. I just equate these two with the 0. How? X square plus 4 is equal to 0. X square minus 4 is equal to 0. We just write this first one. So x square is equal to minus 4. Is it okay? That is equal to, x is equal to square root of minus 4. How it becomes? In root there is minus 4. Don't bring that minus 4. It's an imaginary number. Square root of minus 4 means it's an imaginary number. In the square root of, just it is, if it is square root of 4, then you will bring that, then you will convert that number into plus 2 and minus 2. But it is not possible. It's an imaginary number. If there is a negative number in the root, you don't take it out as a general square roots. Okay, that implies you will get plus square root of minus 4 minus square root of minus 4. You just write just like this itself. These two are imaginary numbers. Imaginary numbers. Here x square minus 2 square. You just write this 4 as 2 square. That is equal to 0. So it is again in the form of a plus b into a minus b. A square minus b square, that is a plus b into a minus b. So it converts into x plus 2, x minus 2 is equal to 0. We just equate again with the 0. Then it becomes x plus 2 is equal to 0. X minus 2 is equal to 0. X is equal to minus 2. X is equal to plus 2. How many zeros you will get here? 2 zeros. So 1, 2, 3, 4. 4 zeros. Why? Why we got 4 zeros for this given polynomial? Why? Because it is a 4th root polynomial. For the linear polynomial, the highest degree is 1. Then you will get only one value. For the quadratic polynomial, you will get 2 values. Why? Because it has highest degree 2. Highest power 2. For the cubic polynomial, you will get 3 values. Why? Because it is a cubic, that is that the highest power is 3. Here it is a 4th degree polynomial. Hence you will get 4 values. Okay, these are the 4 values of the 4 zeros of the given polynomial. Okay. Then I'll tell the graphs. Firstly, after completing this 4th sum, then I'll tell this graphs. Okay. So first of all, I'll explain this 4th sum. So 4th sum, y or 1 by 4 and minus 1 are the zeros of the given polynomial. Y means we have to check. We have to check this 1 by 4 is a 0 of the given polynomial. Is minus 1 is the 0 of the given polynomial. We have to check. Okay. So given that the polynomial p of x is equal to 4x square plus 3x minus 1 plus 3x minus 1. So firstly I want to check p of minus p of 1 by 4. Okay, p of 1 by 4 I want to check. Okay, so in the place of this x I have to substitute this 1 by 4. 4 of 1 by 4 whole square plus 3 of 1 by 4 minus 1. That is equal to 4 of 1 by 1 square means 1. 4 square means 16. 1 square means 4. 1. 4 square means 16 plus 3 into 1 3 by 4. 3 ones 3 by 4 minus 1. That is equal to 4 has to be cancelled with 4, right? 1 by 4 plus 3 by 4 minus 1. Now just imagine the denominator there is a 1, right? Take the LCM of these 3 terms, that is 4 which is in 1 time in the 4 table, that is 1 ones 1 plus in the 4 table 4 it become only 1 time, that is 1 3 is 3 times. So minus in 1 table 4 times, 4 into 1 4, that is equal to 1 plus 3, these two are the positive numbers, 4 minus 4 by 4. So 4 minus 4 0 by 4. If there is a 0 in the numerator it becomes a 0. Is this p of 1 by 4 which gives the value as 4? Yes. Hence it is 1 by 4 is the 0 of the given polynomial. Secondly, I have to check with minus 1. P of minus 1. Here two values he gave, that is 1 by 4 as well as this minus 1. That is equal to minus 1 has to substitute in the place of x. P of 4 of minus 1 whole square plus 3 of minus 1 minus 1. That is equal to 4 of, it is even number, in the power there is an even number, hence it becomes positive. So plus of minus 3 minus 1, that is equal to 4. These two are negative numbers, we should add, but the sign has to remain like this. That is equal to 4 minus 4 0. Here yes, 1 by 4 and minus 1 are the zeros of the given polynomial. Okay, and we have the third Roman, that is graphs. Look at here, draw the graphs for the given polynomial and find the zeros. Justify your answer. We have to justify the answer. We have to find the zeros by using of this verification, as well as you have to draw the graphs for the given polynomials. Here I will tell 2 or 3 graphs in this Roman. Just remaining 2 you just draw by your own. Okay, I will tell 3 graphs in this Roman. So third Roman lo first one, that is draw the graphs of the given polynomials and find the zeros and justify your answer, right? Here I will tell 3 questions, graphical representations. I will show that in this video. You just draw these 2. Okay, I will show these 3 graphical representations. You just try these 2 questions by your own. Okay, so the first one is, what is the first one? The given polynomial. So the third Roman in the exercise 3.2, the third Roman, given that the polynomial is p of x is equal to x square minus x minus 12. Let us take it as y is equal to x square minus x minus 12, right? Already I said to you in the before video, that is we have to let us take the p of x polynomial as y, that is y is equal to x square minus x minus 12. So first of all you have to draw the table for this. So y is equal to x square minus x minus 12, it is the second column, and the last column is x comma y. So first of all I want to take a 0. So y is equal to 0 square minus 0 minus 12, that is equal to minus 12. Okay, so what are the coordinates? 0 comma minus 12. Now I want to take the positive number, that is 2. I want to take here 2, that is y is equal to 2 square minus 2 minus 12, that is equal to, here it was 4 minus 2 minus 12. These two are negative numbers, so we have to add this, but the sign is remained just as minus, that is 14, that is equal to minus 10. Okay, so the coordinates are 2 comma minus 10, and the negative number I want to take here, that is minus 2. So y is equal to minus 2 whole square minus of minus 2 minus 12, that is equal to, here there is a power 2, that is even number, so the minus it becomes a positive, so 4 minus of minus plus, that is 2 minus 12, that is equal to 6 minus 12, that is equal to 6 minus 12 means minus 6. So the coordinates are minus 2 comma minus 6. Okay, let us look at the after point out these points. If we need, then we will take the next two points also, next two extension of this table after conclude this graph. Okay, so you just make the graph first. So draw the table. If the U shape which does not give any proper way, then you will take the next two values also. Okay, firstly you just verify it, verification you just do for the conclusion of the is the zeros will come or not for this given polynomial. So p of x is equal to x square minus x minus 12. So the zero of the polynomial, that is equal to x square minus x minus 12 is equal to 0. So factorization, prime factorization, that is x square. So minus x I want, so 12, how it comes, so 4 3s 12, x into x square, and minus x is there, so in front of this bigger number you just keep the minus and plus, then you will get minus x, minus 4x plus 3x, you will get minus x. Okay, so x square minus 12 is equal to 0. From these two we have the common element x minus 4. In this 3 we have, that is x minus 4, that is equal to 0. From this we have two common elements, that is x minus 4 and x plus 3. Remaining elements you have to write here like this. Okay, so verification I am doing here, that is x minus, you just equate these terms with the 0. So you just equate these two terms with the 0. Okay, x minus 4 is equal to 0, x plus 3 is equal to 0, x is equal to 4, x is equal to minus 3. So we just take these two values in the table, extend this table after finishing this verification. It is better to identify the zeros of the polynomial. Okay, you just take the three values in the table first, then after you just do the verification. After verification you will get two values of this polynomial. We just take these two polynomials in the table to extend the values. Okay, then it will show the U shape in the better way. Okay, so what are the zeros here? 4 and minus 3. 4, you just take 4. So we are extending this table. So y is equal to 4 square minus 4 minus 12, that is equal to 16 minus 4 minus 12, that is equal to 16 minus 16, that is equal to 0. Yes. Okay, it is a 0 of the polynomial. No, here we get after verification you will get the x is equal to 4. That means 4, it gives the value as 0. It is 0 of the polynomial. That's why we got this 0. 4 comma 0. The next value minus 3, right? The next value is minus 3. So we just substitute here minus 3 also, it gives the same answer, that is 0 minus 3 whole square minus of minus 3 minus 12, that is equal to 9 plus 3 minus 12, that is equal to 12 minus 12, that is equal to 0. So minus 3 comma 0. So here we have the extension of this table. After verification, it is better to take the two values. Why? Because to identify the U shape, that too it has to intersect at that 2 points. Hence it is very easier. After this verification we can extend this table. Okay, so I just draw the graph to identify the coordinates in a graph. Okay, take the values, that is for horizontal and vertical lines, that is x-axis, y-axis, and the scale. Is there any highest values is there here? Minus 12 is there, minus 10 is there. Is these values are sufficient? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, it is sufficient. Hence I am taking on x-axis 1 unit, on y-axis also 1 unit. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, that means negative numbers. Sorry, I forgot. So minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11, minus 12. Okay, so here, so the first coordinate is 0, minus 12. 0, minus 12. Here on the x-axis 0, minus 12 is on y-axis. Here it is the point, that is 0, minus 12. Okay, what is the second point? 2 comma minus 10. Where is 2 on the x-axis? 2 on x-axis is this one. Minus 10 on y-axis here. Okay, here 2 comma minus 10. And the next coordinate is minus 2 comma minus 6. Minus 2 on x-axis and minus 6 on y-axis. Here it is the point, that is minus 2 comma minus 6. And the next point 4 comma 0. Here there is a 4 on x-axis and 0 here itself. Okay, 0 comma 4 comma 0. 4 comma 0. Okay, the next one minus 3 comma 0. Minus 3 here it was, so minus 3 comma 0 in the same place. Minus 3 comma 0. So these are the points. I just add these all. Just like this you will get the graphical representation. You just extend as you wish. Okay, like this you will get the graphical representation for this polynomials. So what is the conclusion you have to write here? Okay, so from graph, the two zeros are, from the graph, the U shape, from the graph, the U shape touches x-axis at 2 points, that is 4 comma 4 and minus 3. 4 and minus 3. From the graph, U shape touches x-axis at 2 points, that is 4 comma minus 3. Hence there are 2 zeros for the polynomial. That's it. It is the conclusion for this graph. Okay, we just take this graph here and we will finish the first graph. Now it's time to second graph. Okay, so here we have third sum. I just do this two sums by your own. Okay, I am telling this third sum. The given polynomial, given that it is one special sum for you. Why? Because I'll show that by the graphical representation, that is case 3 anamata. Okay, that is case 3. Because why? Because the U shape which does not touches the x-axis at any point. Okay, I'll show that graph here. So the given polynomial, that is p of x is equal to x square minus 4x plus 5. So let us take this as y is equal to x square minus 4x plus 5. The table for this polynomial x. So y is equal to x square minus 4x plus 5. The coordinates are x comma y. First of all, I want to take this as 0. That is y is equal to 0 square minus of 4 of 0 plus 5. That is equal to 0 minus 0 plus 5. Here we have 5. So the first coordinates are 0 comma 5. Now I want to take this 1 as the value, 1 positive from the positive numbers. I want to take this 1, that is equal to y is equal to 1 square minus 4 of 1 plus 5. That is equal to 1 minus 4 plus 5. That is equal to 6 minus 4. That is equal to 2. Okay, so the coordinates are 1 comma 2. Negative numbers also I want to take one more, that is minus 2. So y is equal, here I want to take minus negative numbers, that is minus 2. Y is equal to minus 2 whole square minus 4 of minus 2 plus 5. That is equal to, here there is a power of even number, hence it becomes a positive. That is 2 square means 4, minus of minus plus 4 2's 8 plus 5. That is equal to 12 plus 4 plus 8, 12, 12 plus 5, 17. Here the values are minus 2 comma 17. Okay. So 2, here I want to take one more positive value, that is 2. Y is equal to 2 square minus 4 of 2 plus 5. That is equal to 4 minus 4 2 is 8 plus 5. That is equal to 4 plus 5, 9. These two are the positive values, minus 8. That is equal to 1. So here 2 comma 1. These are the values. First of all, I want to check the graphical representation by using of these values. First of all, in the before sum, what I said to you, the verification before going to draw this graph, you just do this verification first of all. Then you will get the two values from this verification. No, you just substitute that values in the table, right? We will check this verification of this polynomial also. What is the verification? The prime factorization of the polynomial, right? So the 0 of the polynomial, what is the 0 of the polynomial? What was the given polynomial is x square minus 4x plus 5 is equal to 0, no, right? So you just take the 5x square. What the values has to be taken for this? Here 2, right? If I want to take 5 into 1, 5 ones 5, x into x, okay, 5x square, but I need this minus 4x. If I keep minus in front of this, plus in front of this, okay, minus 5x into 1x is not equal to 5x square, no, minus 5x square you will get. Minus 5x square you will get. If you multiply these two terms, then you will get minus 5x square, not 5x square. Then it is not correct. So the verification is not possible for this kind of polynomials. We just check by our own ones. Okay, the verification is not possible for this kind of polynomials. Is there any solutions? Yes, there is a solutions, but in your 5th chapter, that kind of polynomials we will solve by using of in different methods. Okay, at that chapter I'll explain to you how we have to solve this kind of polynomials. But here by this verification we shouldn't get any values for this x. Okay, there is no verification, there is no prime factorization for this kind of polynomials. So you will not get any x values. So you will not get any x values here. Okay, so how can we draw this graphical representation then? So I will show here. Okay, so take one graph. Okay, x-axis, y-axis, scale on x-axis, on y-axis. Okay, how should we have to take? 17 is there here, so only the 17 is there, so we will check. So 17 will not come at this for this kind of numbers. So 2 units on the x-axis and 1 unit on y-axis. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. And on the y-axis 2 units we are taking, that is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, here also minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14, minus 16, minus 18, minus 20, minus 22. Okay, just like that. Okay, what is the first coordinate here? 0, 5. 0, 5. In between this 4 and 6 we have 5. Here we have. Okay, so 0, 5. Yes. Then what is the next number? 1, 2. 1, 2, right? So 1, 2. Here we have 1, 2. So 1, 2. And what is the next one? Minus 2, 17. Minus 2 on x-axis and 17. In between the 16 and 17, 16 and 18 we have here we have the point, that is minus 2, 17. Okay, and then next point, that is 2, 1. Here on x-axis 2, 1. Here we have 2, 1. 2, 1. I want to take some more on positive side, so then you will get the U shape, otherwise it will not get U shape. So I want to take here the 5. So to extend the table, I want to extend the table. Why? Because I will not get the certain U shape, that's why I want to take some more value, that is 5 square minus 4 of 5 plus 5, that is equal 25 minus 20 plus 5. Here these two values are positive, hence 30 minus 20, that is equal to 10. So I want to substitute this 5, 10 in a graph. So 5 here on x-axis and 10 is on here. Okay, here. So 5, 10. So I think it is enough. So we just join this. Extend these lines, no problem. Okay, just join this. this. Okay. So it is U shape. You will get the U shape, but this U shape which does not touches on x-axis. Why? Because on the verification also we will not get any solution. In the verification also we will not get any solution. Why? Because there is no x values. There is no zeros. That's why the U shape also which does not touches the x-axis. Right? So what is the conclusion you have to write here? From the graph, the U shape does not touches x-axis at any point. Hence, there is no zeros. Okay, it was a conclusion for the third sum. Okay, just like this. So, when you are doing graphical representations for the quadratic polynomials, you just extend your tables to identify the coordinates of this x and y. After verification, it is better to do the after verification. After verification, you will get 2 zeros. If you will get 2 zeros, then the graph which touches the U shape which touches 2 times. If you will get 2 equal values, then the graph which touches only once. If you will not get any verification for this, any x values for by the using of this prime factorization, in the verification you will not get any x values, then the U shape which does not touches at any point, then there is no zeros. It means there is no zeros. Okay, I think you better understand this kind of quadratic equations also. Here the next I will explain this fifth sum. Okay, fifth sum. Fifth one, that is given that the polynomial p of x is equal to x square minus 1. X square minus 1. The 0 of the polynomial. Here we have to take this y is equal to x square minus 1, right? X square minus 1. We have to make the table for this, that is x. Y is equal to x square minus 1, and the last one is the coordinates of this x and y. Here I want to take this first as a 0, that is equal to 0 square minus 1, that is equal to 0 minus 1, that is equal to minus 1. What is the coordinates of this x and y? 0 comma minus 1. Here I want to take one positive number, that is y is equal to 1 square minus 1, that is equal to 1 minus 1, that is equal to 0. What are the x and y coordinates? 1 comma 0. The negative number I want to take here once, so that is minus 2. So y is equal to minus 2 whole square minus 1, that is equal to even number. So minus 2, the negative number I want to take here. So you just substitute in the place of x, minus 2 whole square minus 1. Okay, here there is a power, that is even number. So hence the minus it becomes positive. So 2 square means 4 minus 1, that is equal to 3. What are the coordinates? Minus 2 comma 3. 2 more values I want to take here. One positive value also I want to take here, that is 3. So y is equal to 3 square minus 1, that is equal to 9 minus 1, that is equal to 8. So 3 comma 8. Negative value I want to take one more, that is minus 4. Y is equal to minus 4 whole square minus 1, that is equal to 16 minus 1, that is equal to 15. If it is there is a 15, then we will substitute, otherwise you just leave it. Okay, so minus 4 and comma 15. These are the coordinates of this polynomial. Okay, so you just make the table. So after finishing this, you will check the values of the 0 also by the verification method. Okay, I just make the graph. Here we have x-axis, here we have y-axis. What is the scale? I want to take only 1 unit on both of this axis, that is on x-axis I want to take 1 unit, on y-axis also I want to take 1 unit. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and leave it. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11. Okay, just like this you have to prepare your graph. And what are the first coordinates? That is 0, minus 1. 0 on the x-axis and minus 1 on the y-axis. Here we have the first point, that is 0, minus 1. What is the second coordinate? 1, 0. Here only we have the second point, that is 1, 0. Okay. The third coordinate, that is minus 2, 3. Minus 2 on the x-axis and 3 on the y-axis, that is minus 2, 3. Okay, minus 2, 3. And the fourth coordinate, that is 3, 8. 3, 8. Here we have 3, 8. And the next one, minus 4, 15. There is no 15. I am leaving this value. So you just join this one. Okay. If you want to extend this value, you can extend this. Okay, like this you just extend this lines. You will get u value, right? U value. What are the zeros of the given polynomial? Here there is a 1, here there is a 1. By the verification we will find this verification, that is the 0 of the polynomial, that is x square minus 1 is equal to 0. X square is equal to 1. X square is equal to 1. X is equal to square root of 1. X is equal to plus or minus 1. So hence you will get a 2 zeros, that is x is equal to plus 1, minus 1. So here also you will get, when you drawn this minus 1, when you will take this minus 1, you will get 0 as it one. Approximately you will get this u shape. So plus 1 and the minus 1 are the given zeros of the polynomial. So here you have to conclude this. How you will conclude? So here from the graph and the graphical representation and from the verification, you will get the zeros as the plus 1 and minus 1. There are 2 zeros. There are 2 zeros. 2 zeros for the given polynomial. Why? Because the graph which touches 2 times on the x-axis. Why? Because the u shape which touches 2 times on the x-axis. Okay. Hence there is 2 zeros for the given polynomial. Here we have up to 3.2. We finished this graphical representations of this linear, cubic and quadratic polynomials. So we finished up to this 3.2 exercise. Tomorrow I'll upload the next part, that is about the examples and exercise of this 3.3. Okay, thank you.